So when considering basic exponents, there are several rules that you should be quite familiar with. The first one is something you might call the multiplication rule, but it's whenever you have a base that's the same and you're multiplying by another quantity. So in this case, both of our bases, x, are the same, and I'm multiplying them together. This is just x times x times x, and this is x multiplied by itself 7 times. So in total, I'm multiplying x by itself 10 times, or 3 plus 7 times. And then, of course, the general rule that we can gather from this would be x to the a power times x to the b power equals x to the a plus b. So calling it the multiplication rule, really what that's telling you is that the original problem is multiplying. If we look at a similar situation and we divide, well, this is like having 7 x's on top in the numerator and 3 below in the denominator. And then we see that canceling out 3 from the top, we cancel out 3 from the bottom, and we're just left with 4. And this is going to work every time, as long as the numerator is larger. And we're left with 4x's on top, or x to the fourth, over just 1. So we would just write that as x to the fourth. And the general rule, or what's happening here, is that we have x to the 7 minus 3 this time, or just x to the fourth. So if I wanted to write that as a general rule, I might write that as x to the a over x to the b equals x to the a minus b. Now you probably remember these rules, and of course we can combine them together. Let's take a look at one more right here before we do any combining together. So let's say that I have 3x cubed times y squared, and then I want to raise this whole expression to the fourth power. Anytime I take a power to the power, I just multiply the powers together. Now this 3 also gets included, so I have to think of it kind of like a 3 to the first. So this becomes 3 to the fourth times x to the 12th times y to the 8th. And you can just see that that 4 here got multiplied by the 3 to the first, the x cubed, and the y squared. A general rule might just look something like this. If I have a to the n power to the b power, notice it doesn't matter what variables I use. That's a to the n times b. And it doesn't matter if it's just one thing being raised to a power, or in this instance where I have 3 examples being raised to a power. You just distribute over the multiplication there, and you shouldn't have any issues. The last one that I want to take a look at is what happens when we have a negative, right? And this is already a little more advanced, but it's not too advanced. It comes from a definition, right? So in math, we look to see what patterns come up and how we can generalize them. So if I have 3 cubed, that's the same thing as 27, and 3 squared is the same thing as 9, and 3 to the first is the same as 3, and these you're all familiar with. But as we move down, on the right-hand side, we're divided by 3 each time, and on the left-hand side, I'm basically subtracting 1 from my exponent. Now, for this pattern to continue, 3 to the 0 would have to be equal to 3 over 3, or just 1. And if I wanted to continue this into negatives, then this would have to be equal to 1/3, and so on and so forth. Now, once we get to 1/9, we can rewrite that as 1 over 3 squared, and this is kind of where our general rule comes from. Anytime you have a negative exponent, so if I said 5 to the negative 3, you can imagine me carrying this pattern down until I got 1 over 5 cubed, or 1 over 125. So the general rule that we can write here is anything, say x to the power negative n, is the same thing as 1 over x to the n. A lot of people want to make the x negative, but that's not true. It's only that the negative takes this and then puts it in the denominator. The same thing could be true if you had x in the denominator that's negative. So let's imagine that I have 1 over x to the negative 3. Well, our rule still holds, right? X to the negative 3 we know is the same thing as 1 over x cubed. And so this expression becomes 1 over x cubed, which we know from dividing fractions that you multiply by the reciprocal, which is x cubed over 1, or just x cubed. And so you might have noticed it started out negative in the denominator and ended up positive, and we could think of this as in the numerator. And anytime I do that change, if it's 1 over x to the negative n, and I want to move that into the numerator, the same pattern holds. It's x to the n over 1. Likewise, if I have 3 to the negative 5, and I think of this as in the numerator, then I can move that to the denominator as 1 over 3/5. And notice kind of as it switches from numerator to denominator, it just goes from negative to positive. And that's the only sign change that you'll see with exponents.